The question goes like this. A manufacturing company prepares spherical ball bearings, each of radius 7 mm and mass 4 grams. These ball bearings are packed into boxes. Each box can have a maximum of 2156 centimeter cube of ball bearings. So this sentence means that the volume of the box is 2156. Find the subdivision A maximum number of ball bearings that each box can have. If the space inside the box is divided by the space occupied by one ball bearing, then we get the number of spheres. Number of spheres is equal to volume of box divided by volume of one ball bearing, which is 2156 centimeter cube upon 4 by 3 pi r cube. Here r is the radius, which is 7 mm. The radius of the sphere is given in millimeter. So either we have to convert the volume to millimeter or convert the radius to centimeter. Converting the volume to millimeter cube. So 2156 times 1000 millimeter cube upon 4 by 3, 22 upon 7 into r is 7 millimeters. On calculating this, we will get 1500. That is, the maximum number of ball bearings that can be kept inside the box is 1500. Subdivision B, mass of each box of ball bearing in kg. The mass of one ball bearing has been given, which is 4 gram, and the number of spheres that can be kept inside the box is 1500. Therefore, mass of box is 1500 times 4 gram, which is 6000. On converting this to kg, 1 gram is equal to 1 upon 1000 kg. So we get 6 kg. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos.